At this stage of the course, the author of these texts at this level tend to talk about differentials and linear approximations, maybe even equations of tangent lines. And I just think it's all silliness because it's all the same thing. I've already discussed and used it in practice how to come up with an approximation of the output of a function using differentials. But let's go back to our standard equation of a tangent line, to the graph equation y equals f of x at x equals a. There it is. If I isolate y, does that mean this? Now this y is the y-coordinate point not on the graph of the equation y equals f of x, is the y-coordinate point of a point on the tangent line. That being the case, this is the output of a linear function. Let me call it as such. This is what I refer to as my local linearization to f at x equals a. It's just an alternative way of approximating things. For example, oh, whoops, silly me. For example, let's see if you and I can't use a local linearization to answer my last question. I'm sorry for wasting a bit of time erasing. I should have done this beforehand. So here we go. Now I'll choose a local linearization about a equals 36. And there's my local linearization for my function f at a equals 36. Now I still haven't answered my question. And I think last time we approximated root 38, I think it was 6.16 with a bar. I better get exactly the same approximation because I think the techniques are basically the same. Let's see if I do. So oh, by the way, before I get started with this, notice how that's a linear function. If it's not linear, something's gone wrong. So let's see if I can evaluate this at 38. Oh, it worked. Thank goodness I got the same value I had last time. There is using a local linearization to get the same value. I have to confess, here's my equation of a tangent line. I just massaged it to look like my local linearization, but technically speaking, if you think of that as just a small change in the x direction, replace that with delta x, that's exactly what I have over there. So I do think they are all nothing more than different ways of writing the same darn